you feel weak, run down, and are easily upset,
We are striving
start taking
Iron Realm Media.
today.
It's Friday, my dudes.
Well, TGIF. Happy Friday, everybody. Welcome to Have No Sphere, right here on the Iron Realm Media YouTube channel. My name is Josh Corey. We're going to jump right in because we have got a super exciting show for you all out there tonight. It's going to be a doozy. I'm pretty excited about this. Let's just jump right in and say hello to one Mr. John Savage. John, have you gotten your certificate yet?
Yes, I have.
Yeah, that's what I like to hear.
Finally. Yeah, for anyone who doesn't know what I'm banging on about, my plumbing exploits, I've been trying to rig up a wood-burning stove to a water cylinder for about 18 months now. Starting from the very beginning, installing it all myself, then running up against bureaucracy and bullshit. And finally, yes, today, as the weather is set to plunge down to 3 degrees on Sunday, which is, I don't know what, in American, 36. And, yep, I have a toasty little house and a free cylinder of hot water. So I'm a happy bunny. I am a happy bunny and might be a little giddy, so feel free to tell me to shut up.
Nope, I am super happy for you.
Thank you.
Congratulations. Look at you. Free hot water. Can't beat that.
You can tell I'm smiling, can't you? Without even looking.
Sure.
Anyway, yeah, looking forward to the show. So, yeah, good stuff.
That's so awesome. Let's head on over and say hello to my co-host from this morning, one Mr. Walter Johnson. Disc checks complete. Live and in person. Walter, how was your Friday, sir?
It is Friday, my dude. Yes, we made it. We did a morning show, and now we're doing an afternoon show. We have an exciting presentation coming up with Chris UK. I am excited about it. I'll probably be turning my camera off soon. I just want to say hello to everybody, but yeah, my system is stuck, so I'm going to say visually goodbye, but I'm here. How are the rest of you guys doing?
Oh, so far, so good. You know, John Savage got a plumbing certificate, so now he has free hot water. There's that.
I heard. That's awesome.
Yay! I'm like a kid. Sorry.
Well, let's head on over to say hello to the Adam Meakin. Adam, sir, broadcasting live from the Iron Realm Media Studios there in Nottingham.
In me shed. Hey, well, I don't know. I was going to say something, but it's just there's no bigger news, is there? Is
There's
it true,
not.
John? Is it really true?
I know, it's incredible. I'm going to frame it. I'm actually going to frame it and put it on the wall.
I want to see a picture of it in the front. I want to see a picture full stop.
I've got one. I've got a picture of the stove lit, and it's got all sorts of wires and stupid valves and all sorts of shit all over it, which may or may not be coming out later, but I have a certificate. It is legal, and everyone can piss off out of my house now.
Put that in your pipe and smoke it.
I'm happy. Congratulations to you and the soon-to-be warm Savage family.
Thank you.
I bet Mrs. Savage is ecstatic.
Not quite as ecstatic as I am, but she's she's the chalk to my cheese. So yeah, she's suitably. Well done.
Well, that's still pretty awesome. And since we are missing our brother from down under, Rob, who is time traveling actually, and it's Saturday, so I guess it's all right. We'll just go ahead and head on over and say hello to Zachary Zabala, or here on YouTube, Good Times for All. the Nomad, the Stay Puffed Marshmallow Man, Navin Johnson, and
Nomad.
I think I got that one. I'm still
Did
missing.
you? You're missing one. What is it?
I don't know.
2 Nights for Rice.
That's the main one.
That
Shit.
was the first one you guys gave me.
That was the first one. Well, Zach, how was your Friday, sir? You've not even been to bed yet. You've been up since way early, since like Ironworks early, and have not even had a nap.
No, it's weird. I don't know. We were talking about that eclipse thing this morning, and it got me going. And I started doing a little bit more research, and then I started drawing pictures, and then I looked up, and it was like, whoa, it's like 11 o'clock. And then I don't know. I'm up. I didn't get tired. I'm still on like Flattoberfest times where you only sleep a few hours a night, and it's all good.
Well, if you can do it, I say cheers. Good on you.
Yeah, we'll see. I'll probably be crashing like right after this is over, I'm sure. My eyes are going to just boom.
It's a good sleep, though.
Yeah. Oh, yeah.
Yeah, it makes for a long Friday. It does. It does indeed. But I do appreciate you hanging out with Walter and I in the mornings.
No, I love it. I love it.
Well, we've got an exciting show planned for today. We have Chris UK. You can find him here on YouTube. And he's been doing some questioning. And he's been going out, hitting chat rooms, talking to physicists, posing questions, and finding their answers have been coming up short. So he has decided to come on with a little bit of we put out a video. So we watched the video, and we're going to go over some of the finer points and discuss it, because this is one of those things that I've heard proponents of a spherical Earth use in their arguments. And I think this is going to be a super exciting show, because by the time you all leave here tonight, you will be armed with some excellent information. So let's just jump right in and say hello to Chris UK. Chris, welcome to Have No Sphere and the Iron Realm Media YouTube channel. Thanks so much for coming on.
Hello. Hi. Thank you very much for having me.
Good evening, Chris.
Good evening. I'm rainy Rochdale.
Good to see you again, Chris. Looking forward to this. I see you got the whiteboard in the background.
Well, I might not use it yet. I don't know.
Oh, okay. You tease.
Yes.
Well, you know it's going to be a good night when there's at least the possibility of a whiteboard.
I'll draw on it then, okay.
So give everybody a little bit of background about exactly how it is you came to make that amazing video.
Well, I've been working on this idea for 12 months. Everyone knows that it was a planet circling and moving about, blasting through the galaxy, that there should be movement somewhere. We should feel it. You know, your instinct tells you, common sense tells you. So I got down and worked out the physics of it eventually, and realized that we should be feeling something. We should be feeling something on Earth, and we should be feeling something, or seeing something on the ISS if it was real. So I worked out the physics myself in my head, and then I started asking questions, going on boards, going on forums, and asking, well, if we treat the Earth as a rigid body rotation or a revolving object that is moving, which in physics is called rigid body rotation with translation. And they just didn't want to know about it. They just couldn't picture or understand what I was on about. And I spoke to quite a lot of people. And I got to 2 physics guys who realized the point I was making in 2 separate incidents. And when they got it, they were telling me, I can't put this information out. No one will understand it. They won't get it. No, it's wrong, but they won't understand it. Don't put it out. Because they didn't understand why it's not talked about. And it isn't talked about. This little section of physics is jumped over from the globe physics, with it revolving and standing still, they jump straight out to the going around the sun. But that actual movement involves more physics, and they ignore it. And it's telling, because you don't see any physics talking about a rotating sphere that's moving. They go all around the houses trying to explain a rotation, a point on a rotation moving, but never show a sphere. They show a distorted bar or a rock with 2 points. And it's just, I think it's obvious this is a big Achilles heel to the globe. And some of them know it, some of them don't. So from that journey, got together with Harry. He got it straight away. And we put this movie together, this clips. It's not brilliant, but it puts the points across, I think, pretty strongly. And it's took 12 months to get here with all the ideas and trying to work it out, but it looks really simple and there's a few mistakes on it here and there, but I'm pleased with it. No one's had any answers yet. Just play around and loop the loop and don't give me any answers. Don't answer the physics.
Well, I think it's brilliant, mate. I think you're underselling yourself. I think it's fantastic. If anyone hasn't seen it, where would they go? What's your YouTube channel? Chris UK, is it?
Chris UK. It's on John Smith Global Eye. It's on the it's on Globebusters.
Actually, I'll put a link in the chat now, just
okay.
Yeah.
So constructive criticism or just help, that's fine. Yeah. And I've not had many trolls. One or two, but not as many as usual. I think they're a bit stumped at the minute anyway.
I think the whole panel's a bit stumped at the moment. What the fuck are you doing, guys?
I've just realised I've been talking going out on there, but I've been muted on bloody Zoom. So
there had to be a reason. What was the name of the video, Chris?
I forgot now.
I've got 3 or 4 ISS constant velocity, no way. Chris UK.
It's got a funfair ride on it and me.
Use a field of view to disprove the globe. You put quite a few videos out, haven't you?
I think there's some good ideas there that have been overlooked, but that's another thing.
Okay. Global Eye ISS constant velocity, no way.
Okay, gotcha.
That's it.
Yeah, but before we get into that, that was just what I wanted to say is our own Mr. Zabala, he's already premiered it. I saw him do it. He gave a little sneaky premiere on Jaren's channel about an hour or so ago. But he's just got a little bit of headbending to do first, if that's all right.
That's right. He was totally supposed to pick up when I introduced him. That's why I saved him for last specifically. And we totally forgot.
Damn. So, and that might give us a chance for Harry to arrive. We're still waiting. Hopefully he may do. Not heard anything from him yet, so we'll see. I think I've just heard he's on the phone with Jason, so we'll see. Maybe we can get him to join us. But this is an effort from you two guys. Well, it's yours, and you've collaborated with Harry Dees to help you with production mostly. I think, was it Chris? And
yeah, well, we've been up and down. I've been to Edinburgh. He's been down here a couple of times. We've done a lot of filming. A lot of stuff's on the floor. We never used like a day's worth of filming, and we used a little clip of it. So we try to make it as simple as possible, cut it right down, and it's still 27 minutes, something like that.
Hey, it's pretty cinematic, mate. I thought there's some drone footage of you walking at the end.
Yeah,
very well done.
That's Harry. Harry put it together, did all the editing, put it all together. I did the animation. Well, obviously it's me on the screen, but yeah, Harry did a lot of work.
Excellent. Right, we'll get back to that. Zach, are you ready, bruv?
Yep.
Do you need to screen share?
Yeah, I'm on it.
Okay, give me a second too, sir.
Zach, what are you going to show us?
Okay, I'm all yours.
Okay, this is an eclipse that I kind of came across, actually from Josh and Walt, a hybrid eclipse.
Ooh.
And over there on TFR, Ironworks in the Mornings, they had brought this up, and it was actually an old article from 2013, but it was neat because this shouldn't be possible, I don't think, or we can test it. We can measure it. If it is happening, well, we know it's not happening the way they're saying it, but we can disprove what they're saying. This is just a picture of the different names that they give them. You have your umbra for the dark shadow. Can you guys see my mouse moving around on there?
Yep.
Okay. Then you have your penumbra. That's just the same shadow, just a more narrow part of it. And then an antumbra, which is this little, where the shadow actually crosses over and creates this little cone. And that creates the annular eclipse, which is one of these right here, where you can see the whole sun around the moon. We usually get them, oh, what the hell? I want this open.
And that's the Ring of Fire eclipse, right?
Yeah, exactly. Here we go. This is the one we usually see. The annular eclipse are a little more rare.
We're still not seeing it, mate.
Oh, maybe that one's just not going to pop up. Here you go. Let's see. There you go. Did that pop up?
No, I think you'd have to unshare and reshare it on the screen. Ah, there you go. Nice one.
Okay. So you have your annular eclipse where you can see the whole sun, the ring of fire, and then your total eclipse where the moon is big enough in diameter to block out the whole sun and you just see the rays around it. What's interesting about these hybrid eclipses is it's supposedly, oh, I can't see over there. I'm gonna have to move this real quick.
It's Iron Realm Media, mate. No worries.
Yeah,
You're doing well. We can see you. We can hear you.
Can you see the new picture? Did that
Nope.
pop up?
Nope.
Okay, we're going to have to do a new share. Here we go. There we go.
Yeah.
So before we get to this next bit, Zach, we've got decreasing shadows, first of all.
Yes.
Okay.
So that, now I haven't asked anybody to 3D model this yet, but the way they put it here is that the distance of the moon is different, maybe, because of the curve of the Earth to where it is, the shadow is shown. Okay, let's play along with the fairy tale. Okay, let's say this is possible, right? Wouldn't it get real thin right here, the shadow, as this, because this is the part where you have your ring of fire, and that's only seen up to here. And then that ring of fire goes away and then reappears back here. But this whole time in here, it is a full eclipse, a total eclipse.
Because, of course, they have to maintain that the moon is a constant distance away, albeit it moved 5 millimeters last year and 10 millimeters the year before or whatever, yeah?
Mm-hmm. Yeah, so I'll even give them that. Maybe there is some mathematical way at a certain angle and this and that with this degree and blah, blah, blah. I'll give it to them. I'll just humor them. Wouldn't
Zach,
the shadow almost disappear when it gets to like right here?
When it's there, Zach, after that point, is it then enlarging again, supposedly?
Yeah. Here I have a little.
What's causing that?
Yeah, exactly.
Is there a lens, like a shadow lens, that it focuses to a point and what the what?
Gravitational lensing.
Oh no! Here we go.
You're the master of lenses, Josh. Now, what's going off?
It's gravity. Gravity is lensing the light. I don't fucking
know.
Okay, do you see my little drawing I got here?
Yep.
Okay, you have your annular eclipse, your total eclipse, you got your sun and your moon, and then there's that same shadow pattern, right? And then we have some, let's see, we have our nonsense right here. We're going to take our nonsense and we're going to bring it down here. Oh, didn't do it.
You got to get all the nonsense.
I know it. Sometimes when I do it, it doesn't want to go transparent. And then other times it will. Oh, what the fucking fuck? It's not doing it.
the trouble with when you're dealing with nonsense, Zach, you see.
That's what happens every time. Okay, maybe it'll do it this time. If not, I'll just leave it. No, it's not going to do it. Oh, this is going to make it mad now.
You're going to have to move the nonsense.
He's trying to, John.
No, the word.
No, it's not doing it. It's supposed to be transparent. It says transparent.
Maybe a larger selection.
There we go. See, is that not crazy? Now it's doing it. I don't get it, but okay.
It's the same to me.
So we start off. Well, no, the corner. See the white part?
Oh, yeah, got ya.
Yeah.
Load of nonsense. Get on.
Okay. So it starts off and we have our little tiny shadow right there, right? Where it's touching it. As it moves up, it's going to get smaller and smaller and smaller to where there's just that little tiny bitty shadow right there. And then as it moves through, the shadow will then again get larger, according to them. And then as it moves back out, it should get teeny tiny again, and then back to the ring of fire at the end, like that.
Yep, makes sense.
So if we put, if we got along the path, it is kind of out in the ocean. There's islands at the start, though. There's islands in the middle, and there's islands at the end. I don't know. We should be able to at least show that it's not doing what they say it does, because I doubt it changes size.
And when's this happening?
March 20th, or no, April 20th, 4/20, 2023.
2023.
Yeah. So we have time to plan. Plenty of time. The first island is out in, let me see, where's it at?
So we have time to convert an entire island into flat earthers and give them some cameras to shoot.
I'd say you're cutting it a bit fine there, mate. 2023. That's nearly 3 years away.
It starts down here in an island. I'm going to destroy the name of it. Something Duprince. It's French. I'm sure I'm saying it horribly.
Yeah,
and then right
destroy
here,
it, mate. Destroy it. Do it.
Yeah, I did. That was the
Good
best I'm going to get out of it. Blah de Prince, blah blah blah. I even listened to a video on how to say it, but I can't do the French thing. And then the midway point, it's right off an island right here in the Indonesia islands here, and then it finishes in the northern Pacific. And where is that?
Oh, we've got Nick at Phuket World. We've got Ravenlocks in Guam. We've got to have a few more around that region.
All these islands right here are U.S. islands. And it's going to end up somewhere right around in this circle, somewhere right around here.
I'm sure.
So if anybody's looking to take a vacation in 2023,
Bob will be in Hawaii, won't he?
Yeah, it's not too far away.
Nah.
But yeah, just something I was throwing out there. I'd never heard of one of these eclipses, and everybody I asked, nobody had ever heard of one.
Or go to the GoFundMe in our description for a 60-foot yacht that we're attempting to purchase. We've got till 2023. The Flat Earth yacht.
So, Zach, just the basic annoyance for me is this shrinking shadow. Is there a straightforward address for this penumbral effect?
You've done this, haven't you, Zach? You've created a smaller shadow than the object casting it, haven't you?
Yeah, using a Fresnel lens, it was possible.
Cheating? Yeah, you did it.
Yeah, I cheated. Yeah. If you ain't cheating, you ain't trying. That's what my baseball coach always told me.
This is something we did, 2.5, 3 years ago, John, weren't it? Messing around doing shadows and trying to trying to do that, and like I said, the only
Not with a lens though.
no, but we would
use
just
a diffracting, defresnaling, mystifying lens. We just used real light, like the world uses.
I tend to think that the lens effect is real though. I mean, it's observable over long distances, you know, over water and that sort of thing. What do you reckon, Zach?
Well, it all depends on what's above our head and what shape it is. I mean, yeah, with the different layers, you probably could get some lensing. To be like a Fresnel lens, though, that's almost like the dome shaped. Like this, it's just flat.
That's what I was thinking. It's like a lot of little individual domes or something. I can't remember how they set it up, but yeah.
Yeah, they use them on lighthouses. That's what they were designed for, to make the beam nice and
the
tight.
Old school big screen TVs. You guys want to get some nice Fresnel lenses that you can put in your bug out bag and take with you that'll start a forest fire. You can get those old big screen, big box, heavy, gigantic front screen projection TVs. They use the Fresnel lenses there too. You can just pop them right off.
We started a fire, actually. We were burning KMB's cardboard for it. We were playing with fire is what we were doing. And we used a Fresnel lens to start it. Yeah, we were out there playing. And we're like, we were playing with the Fresnel lens. We're like, I wonder how long this would take to start a fire. And then somebody just had to ask the question. And I was like, okay, let's go find out.
Well, it beats burning ants, I suppose. The Fresnel lens is like concentric circles out, isn't it? Okay, so it's like a personal, what was it, atmospheric dome?
I'll be right back.
Dun, dun, dun.
Speak up, Zach.
See, I've learned to live with these pregnant pauses, no matter how squirmy I feel about them. But
let me get a good one out here. Yeah, they come in all different. You can get them in all different magnifying, but it's. I don't even think you guys can see it. I can't tell, but there's circles.
That's a bit
that
weird.
Start right at the center and just keep going out.
Right, that's what it is. It's circles. Okay,
Yeah.
I had played with them.
I love it. You're just like a big talking head.
Ah. Yeah, they're fun. But yeah, you can do all kinds of stuff with them.
So,
I have
Zach,
a bunch of them.
just to kind of, this is basically like a lighthouse lens, isn't it? Or
Yeah.
And the purpose of that is to send the beam to a point at semi-distance and then diverge after it. Yeah, so as to extend the beam length.
Yeah,
so
like the
kind of
focal
cheating
length
the inverse
almost.
square law a little bit.
Oh yeah, I got a few.
So they're suggesting then that there's some kind of Fresnel effect of the shadow of the, is it penumbral shadow? Is that what they call it?
Yeah, that's the main shadow.
All right.
It goes penumbral, autumnal, something like that. Let me see real quick. I'll get back in there.
Yeah, but they're just different positions, aren't they, of the same lensed shadow effect that they're claiming?
Yeah, exactly. It's just supposedly different distances between the Earth and the Moon. You're just hitting where the line that the sun and the moon hit, where they overcross. You're moving in between those areas.
But the variance in their model, in the nonsense, the variance of the moon is what, plus or minus 5 degrees off the perpendicular spin axis? What's an easier way of saying that? Equator?
Off the equator, yeah.
That's right, isn't it? So it's only 5 degrees sort of plus or minus. So wouldn't you always get, a total eclipse in the north and a a total eclipse in the south, or am I getting this around the right way? Or wouldn't you?
They have the math supposedly to where, yeah, it's
Math is reality.
mathematics. But
Myth
I've never
magic.
really looked into it. I've never really delved that deep into trying to debunk it because I've never given it that much credence.
I bet they haven't either. I bet they were told it. It just sounded reasonable,
Mm-hmm.
and they went along with it. I bet if you do look into it, or someone does, then
Who's the guy that gives us all of our eclipse predictions?
I forgot his name.
Hang on.
he's some guy in a dumpster in some town somewhere, isn't he? One bloke.
Well, while we research that, Chris, what do you reckon to that then, mate? As you're also a purveyor of nonsense.
I see what you did there, Adam. Well done. You brought the guest in. Nice one.
See that? See, mate, I'm the hostess with the mostess tonight. I've got clips lined up for him and all sorts.
Oh, shit, my lights have just gone out.
There's a big problem with the moon, obviously. And the
Hire an electrician, John.
The eclipse just doesn't work at all for me. So it shouldn't happen on a globe with the sun. That's it. Full stop.
Is there a year, does anyone know, when it wasn't just the moon's shadow that was creating an eclipse? You know what?
I don't know.
There seems to be a new convention that they're creating this, like I say, reducing shadow effect. It doesn't. I don't remember this from school days. There was never a need to cater for this gap in the paradigm, was it? Though it seems to be a new. In the old days, I'd said a new science for this. Do you know what I mean? It does seem a new set of bullshit to cater for a whole.
Make a bigger selection, Zach.
This?
Try that, yeah.
What you got? Wait there. You wait for me.
Maybe smaller.
I know. This thing pisses me off. I'll just not do it, I guess. Doesn't work this time. Nope. Break it. I was just going to show you. Yeah, this is the
nonsense.
Yep, with the nonsense. This is the part of the shadow that the moon will be up to this point, and then it'll be this far away. And that's the difference between your annular and your total. The total will be up here, and the annular will be back here. Now, how it goes from one to the other and then back to the other, it would have to change sizes dramatically, especially right here in the middle part. The shadow would be almost null. And we can get people there. That's where there's a lot of people located. I'm sure we could find somebody, Nick down there maybe, somebody down there that could make some observations for us. Maybe have a drone flying up in the air or something. And it should definitely be different than where it is at the beginning and at the end.
Fred Espinac, by the way.
There you go. You reckon this came from Fred Espinac? This
He is
hybrid eclipse?
It might have.
Fred says, oh, by the way, we got a hybrid eclipse coming up. Maybe you guys didn't know about this, but here's how it works.
Right.
Sort of.
Bullshit.
Zach, the way I'm seeing this, right, is that this would mean that every eclipse would be either annular, total, depending on the rotation.
Yeah, this should happen like almost all the time.
Yeah.
But it doesn't. This is very rare. It'll happen in 2023. The last one was in 2013, and the next one will be 2049.
But the dynamics they're describing, every single one in different parts of the Earth should rotate between the different effects, shouldn't it?
You would think.
Yeah, it's been driving me nuts for like a week.
The question is, are we even really rotating?
No, we're not. That's
Well,
a very
let's
good
find
question.
out, I reckon.
Let's find out.
Well, I've heard that because it's so slight that we wouldn't feel it. and because it's constant, we just wouldn't notice it. We'd only notice it if it changed, is what I've heard. Time.
Yeah, I've heard that once or 50 times. And then I say, yeah, but aphelion and perihelion. And they go, huh? And I say, okay, go Google that and come back and talk to me.
Do apologise, I just got plunged into darkness. It was only a bulb. It was only a
I thought he was going to tell me the heating had blown.
I did run inside and just check.
Right, shall we get on with this? Chris, are you about ready, mate? I see you having a slurp.
Anytime you
Zachary.
like. Anytime you like it.
Excellent. Right. I think probably the best place to start, mate, if you want to go just give a little introduction. I'm going to play the actual video concept from your vid, because I think it's just a great way of portraying the points, both from a physics and emotion point of view, but also from an experiential point of view, to exemplify that you would bloody feel these forces if they were happening. Because look,
would. Yeah, you would. Well, I'm pointing out a part of physics that's overlooked by the globe model deliberately, because it just puts a big hole in it. They jump from the physics of a ball spinning and not moving, and then they move the ball and say it's moving around the sun, and ignore the physics of the ball rotating and moving at the same time for a point on that ball. That's totally ignored, never looked at. It's mentioned slightly, but then they just carry on and go on about the physics of the ball around the sun and gravity and centrifugal force. So this points out the bit that's missing, basically. That's my introduction.
excellent. Right. Well, if you give me a second, guys, I will line the video on. And we should be.
I gotta say real quick, I think this is genius.
I'm not a genius. Common sense.
No, just a genius idea. Yeah, I feel the same way whenever I come up with an idea. Yeah, people say that's like, no, I'm not a genius. But yeah, great idea, man.
Thank you.
Yeah.
Okay, guys, I should have shared that for you.
I see it coming up.
Hurrah! Okay. Why is it not coming up over here? Just give me a sec. Aha. Will you just try the soup?
Have fun storming the castle.
Okay. All right, guys. So I'll if you move up, I shall press play. It's about 4 minutes long, so it just should give you a little introduction to the concept. So here we go. Speak up quickly if people can't hear it. Chat as well, please. There we go.
Here on Earth, we can stand on a mountaintop and we can't feel movement. In space on the ISS, astronauts can float and not feel any movement because we're told we're moving at a constant speed through space, revolving at 1,000 miles an hour, traveling through space at 67,000 miles per hour. So we just can't feel anything. Is this true? So we're looking at two constants. The constant spin of the globe at 1,000 miles an hour and the constant speed of 67,000 miles per hour as we move through space around the sun. Constant speed. Now, it doesn't matter if we're doing 67,000 miles per hour through space or 500 miles per hour on a jet plane, 80 miles an hour on a motorbike, or 30 miles an hour on a train. As long as that speed is constant, we won't feel any change. But if that speed changes by, say, 10 miles an hour in 10 seconds, we'd notice it. And it doesn't matter what that constant speed is, we'd notice it the same at all constant speeds. Here we have a fairground ride. Now we have a disc that spins at a constant speed, and the disc, while spinning, moves along the track. So what we're looking at is the speed along the track. So if you look at the wizard at the centre, what speed he's doing. backwards and forwards, and then you as a passenger, as you spin, what speed are you doing along the direction of the track? As you spin, you're accelerating and decelerating faster and slower along the track. So pick a person and watch them as they move backwards and forwards as they're spinning. And let's say you pick the man in the red dot. Now he's accelerated from the blue dot position to come level with the side of the wizard. So he's going faster than the wizard to catch up with him. So here we have the man in the red dot again. He's moved ahead of the wizard and he's had to decelerate to get to this point at the side of the wizard. Here we have a top view of our ride. The base is revolving. It's not moving side to side. Everybody in the ride is at a constant speed around the circumference of the base. If this changed in a short amount of time by, say, 2 miles per hour, people will be jolted from side to side. Well, this is our first constant. Our second constant. The base isn't revolving, it's just moving along the track. As it moves along the track, everybody is moving at the same speed. At a constant speed. How have this changed? Again, by 2 miles an hour in a short space of time, people will be jolted forward or backwards. Now let's combine our two constants. We're revolving at a constant speed and moving along the track at a constant speed. Now you're the dark green spot moving along the track. The only part of this circle moving along the track, moving at a constant speed, is the middle. As you move along, you're accelerating and decelerating along the track. So here the centre of the disc is moving at a constant speed, but you are decelerating to get to the back of the centre. So here again, the centre is moving at a constant speed, but you are accelerating to get ahead of the centre. As you're rotating around the circumference and that centre point is moving in one direction, you're constantly accelerating and decelerating as you rotate in the direction of the base.
Okay, guys, that's over to you, Chris, if you want to, mate. I mean, for me, that's the
first section, right?
Yeah,
So the globe model is based on constant speeds. It's got to be to feel no movement. Everything's got to be constant, and any changes have got to be over a long period of time. So I've got something lined up here.
Well, just before you get into that, mate. I mean, for me, this is what I thought was brilliant about what you've done there in that vid was to make this relatable to real life, to put into effect the forces that you're describing, okay, for later on into a relatable form as something that's translatable to what's actually happening that somebody could go and do. And if you went on that fairground ride, that is a absolutely brilliant example of what we're going to get into later with regards to the Earth and orbital and translational movement. And I've been on one of them. It's like it was a Lego one. So they were all little Lego ponies. It was the Guild Lego one at Legoland in the UK. But it is it's really quite weird because the speed and the pitch change of forces that you feel on your body, a bit like in the waltzers, similar thing, is so noticeable, and it's that constantly changing acceleration, deceleration, and the different placement of centrifugal forces as well that really makes the rides fun and kind of nauseating as well. Do you know what I mean? But yeah, so for me, that's the genius of this concept is to spot this and to
Yeah,
and
but the
expand.
fairground's just spinning round. You're just spinning round, but you don't feel that dramatic accelerations and decelerations till you're actually moving in a straight line. And that's what causes, and what should cause, the problems with the globe if it's moving and spinning at the same time. So it is it's a simple concept, but it's hard to put across simply. Yeah, but the fairground ride is a key one. Harry, great thanks to Harry, got it straight away. That if you're sat on that fairground ride and you're on that ride, belting backwards and forwards, you will feel an accelerations and decelerations. So that's proving the concept that if you're rotating and moving along a track, you'll feel them, and it's changing. It's the change that's happening as you sat there that we're trying to put across with that fairground ride. And it's obvious because we've all been on these rides that revolve and move. And when they revolve, it doesn't get exciting until it starts moving. It's that movement and revolving that changes the whole ride. So, and most of them rides are called UFO rides. So the disc spinning and moving along the track. So that tells you something. If you're on a UFO in space, traveling through space, that's exactly what you feel.
In the old days, John would have been the one shouting, "Spin me faster!" I know it was you that waltzers is the thing that to me is probably the most applicable, because you've got one orbit and then a center spin as well, and it's probably an over accentuated orbit in terms of how narrow it is. So you'd feel that centrifugal effect of the secondary orbit if you're talking heliocentricness. But
well, maybe not everybody's been on that ride, but think of a tilt-a-whirl. I think almost everybody's been on a tilt-a-whirl, and that thing, you can feel it a lot. I mean, and it is going up and down, but you really you'll spin real fast, and then sometimes you just like don't spin, and then you'll catch that and you'll start spinning again, and there's a lot of different forces going on.
Yeah, and a lot of different names for a lot of different rides, so that might be part of it too. That's the one with the little cup type, not cup, but like,
yeah,
like
it's kind of like a cup.
half dome,
circle.
Yeah, half dome thing you sit in, and it spins as it goes up and down that fixed point, but the fixed points are all rotating around on the track, kind of. Yeah, we should probably show some.
What do you call it, Walt?
But that's what we call it, a tilt-a-whirl.
Tilt-a-whirl.
I think the waltzer you're talking about, we call it a scrambler here in the States, I think.
Yeah. But the tilt-a-whirl, that was like at the carnivals that would come around to your local fairs and stuff like that.
Absolutely.
You didn't have to go to a park to go on one of those. Those are more, they came to you.
The point being that whatever we call it, we all know that there's points of acceleration and deceleration that we feel as the translation occurs of the application of these different forces, and because you've got one linear motion, let's assume on the waltzer tilter thing, it's that big circle, we'll call that straight when we're thinking about orbiting the sun, but then you've got that rotation, that orbit, and when you apply those two together, it's not so much experiencing one or the other, it's when you put the two together, because you could spin yourself in that carriage, couldn't you, and you wouldn't feel sick at all, really. But when you put those two motions together and the changes that it creates, it's that creates the disequilibrium in your senses. Are you with that, Chris? Is that
I am.
are we
right.
on the right track?
Combine them together instead of just having one at a time, which is what the globe model does. You have one at a time.
Well, maybe I'll drag another couple of vids. I've got 2 vids here, and it takes it onto the globe model, mate.
Has anyone heard an argument, and I had this argument put to me by a baller for some reason, and I can't remember why, that the Earth's rotation is not constant, and they've got a name for it. It's something like Earth shift or something, that says even the rotation of the Earth speeds up and slows down. It's like I don't know, like a Satsuma.
That sounds like nonsense to me.
Absolutely nonsense without belief. But he pointed me to a sort of peer-reviewed scientific paper about this shit,
hell, yeah.
and it must be real, obviously. So, but has anyone else heard that or had that thrown at them?
23 hours, 56 minutes, and 4 seconds.
It started
That's
slow.
the rotation. The stars slow down.
It's zero wobble too.
But this is a claim that the Earth, and it's a heliocentric claim that it's one of these stupid articles that says, and we all thought everything was constant, but what we're living on isn't. It actually speeds up and slows down by 1.5 centimeters every 24 hours or something ridiculous like that. But yeah, I was just thinking to even call Earth's rotation constant at this point, they contradict themselves left, right, and centre. I've found a BBC article about it, but that was talking about the wobble. You come across the wobble of the poles and that.
Oh yeah.
Yeah.
And like you say, you would feel it. I mean, we can all feel.
Do that with the gyroscope, John. You should know. Make the gyroscope wobble around the pole.
My interest in gyroscopes has been reignited by Rob Durham and his recent purchase, and I'm not going to say any more than that. But yeah,
no, we'll get into that. That's later on, maybe, mate, because that's something that's got my jiggle on a little bit.
All right, no worries.
Right, I'm ready to go, guys. So because I've got 2 little clips. First about 5 minutes. The second one just a couple, but it should, with the great graphics and everything that Chris and Harry's done, exemplify the point for then Chris to build on. So this is the kind of the main body from a straightforward physics point of view. There's no direct maths, but just the mechanics, really. So you guys got the screen as well, yeah?
Yeah, hit play, bud.
Right, I'll press play and then I'll mute up and I'll see you in a sec. Okay.
So how do we know what direction the Earth is moving around the Sun? On the lit side of Earth, the Sun's terminator line gives us the direction Earth is travelling at all times. Now this rocket is an example of what's happening to you, say, on the equator or people on the ISS. As we make that journey, supposedly around the Sun at 67,000 miles an hour. And what speeds increase and decrease along that journey because we're evolving as we go. Our rocket's off, it's travelling at over 67,000 miles per hour to catch up with Earth. And then it's ordered to stay a set distance from Earth out of the gravitational pull to follow Earth. Now this rocket is doing 67,000 miles per hour. The solid red arrow on the right indicates the speed Earth is travelling around the Sun at 67,000 miles per hour. The blacked out red arrow indicates the speed of the rocket as it tracks the Moon. It's now set at Earth 67,000 miles per hour, rocket speed 67,000 miles per hour. Our rocket will shortly be ordered to track the Moon as it orbits Earth. The Moon travels around the Earth at 2,288 miles per hour. Our meter on the right hand side shows plus and minus 2,288 miles per hour. So this meter is showing the variations of the speed above and below 67,000 miles per hour. Now this rocket is doing 67,000 miles per hour to keep up with Earth. To track the Moon, it has to accelerate above and beyond that speed. Plus 2,288 miles an hour and minus 2,288 miles per hour. So we're accelerating and decelerating. So now let's have a look at the ISS. This is travelling and orbiting Earth at 17,000 miles per hour, doing various orbits around Earth. We're looking at one orbit. The orbit that goes closest to the crossing of the equator and the Sun's terminator line. Any other orbit will not show us the massive variations in acceleration and deceleration. Our rocket is now tracking the ISS as it orbits Earth. The Earth is travelling at 67,000 miles per hour, so to keep behind the ISS as it rotates around Earth, it has to increase and decrease by 17,000 miles per hour to keep up with the ISS. This is an acceleration and deceleration chart. At the bottom we have degrees of rotation. Now this can be the ISS, it can be the moon, it can be a point on the equator. On the left hand side we have our speed plus and minus. The centre green line denotes the 67,000 mile an hour Earth travels around the Sun. So remember, that yellow dot, which is a point on the equator, it's got to be travelling at a constant speed. 1,000 miles an hour around the circumference of Earth, and 67,000 miles per hour around the Sun. If that changed in a short time, we'd notice it. So the big question is, how's this been missed? Well, given that the Earth moves at constant speeds as it spins, and we don't feel anything. So that's then put in a box, and we're told that constant speed is now travelling at another constant speed around the Sun. So by putting the constant speed in a box, you just think constant speed, and then another constant speed. So it all makes sense. We need to take them out of the box and work them, see how they work together. And when they work together, this is what we get. For us to feel no movement, all speeds must be constant in all directions.
Okay, guys, so just give me a second and I will line up the next video for...
That was awesome, by the way.
Yeah, these are great, man. Impressively done, and your narration nails it.
Thank you very much. And Harry's editing, thank you big thank you to Harry.
Absolutely, Harry does a great job.
Great
I'm
job.
jealous. I'm very jealous. I work on videos and I'm not even close to this good. So yeah, it's great stuff. Great stuff.
Yeah.
Seriously, I was watching that thinking, oh, I hope he does a comparison between the forward speed and the moon speed. And what I was also thinking was that you were going to expand it onto the, like you said, the moon accelerates to, what was it, 2880?
Just chill your skin down, Savage.
Okay.
All that, but it's too much.
Foreshadowing.
Okay.
Let me just play this last bit, guys, because it's just the last 2 minutes, which kind of finishes the summary of this point of the concept, and then we can all have a chirping on that, because that was good. There was another bit halfway through that resonated with me, and I've had to make a little quick note, so I want to talk to you on this in a minute, Chris. But here you go, guys. Here's the last bit.
Look at the ISS. And the ISS does several orbits, so we're told. So if I'm moving along the track at 6,000-7,000 miles an hour, and the orbit of the ISS is that way, then there's no acceleration and deceleration along that constant. But it's the orbit this way that mostly shows how ridiculous the ISS is. If we're travelling along this track at 6,000-7,000 miles an hour around the Sun, and the ISS is accelerating 17,000 miles an hour, then it's decelerating at 17,000 miles an hour. It's constantly accelerating, then decelerating along that 67,000 mile an hour journey. So the ISS does one orbit in 90 minutes. So in 90 minutes, they accelerate and decelerate by 17,000 mile an hour. That's a massive acceleration and deceleration. So how can the so-called scientists on the ISS float as if still in space and be accelerating along that 167,000 mile an hour journey, and decelerating at such radical amounts and still stay floating as if nothing was happening? It doesn't work. Remember, they tell us we constantly rotate, and the ISS constantly rotates at the same speed. That's why we don't feel anything. But rotation with direction, that direction speed needs to be constant as well. So for us to feel nothing, we need to have a constant that way or that way, and this needs to be a constant that way. But as soon as we rotate, us on the edge of the globe or in an orbit, that changes for us. We accelerate and decelerate along that one journey.
Fantastic. Fantastic.
Okay, so over to you, Chris, mate.
Right, okay.
All yours, pal.
I cannot start screen share while the other participant is sharing.
Okay, so give me 2 seconds. Now, you know why that is, don't you?
Someone's messed up.
No, it's because Josh made me a co-host earlier on, so you can't outboss me. It's my authority.
It's
Gotta
not.
respect my
It's because
authority.
you're
Let me
sharing.
stop. Yeah, I'm stopping. There we go. I was waffling where I found the button. if I'm being Right, over to you, Chris,
Right.
and I'll get ready for setup for you, pal. It's a lot easier.
Again,
You
I
see
thought
that?
that was really good. We can
Yeah, I
see
thought that
your.
was-
Again, we can see your file manager.
Can you see the
I'm
picture?
not sharing that. I'm not sharing that yet, Chris. So don't worry. When you're ready, I'll pop the share.
I'm seeing it, but no, you may have to reshare. Zach, you got the hang of it a minute ago, didn't you? Where you had to. There
Is
you
that-
go. Yeah, got it.
You got it.
Are we right?
Okay, so here I am on top of a mountain, and this is my position on the globe at the equator. This is the North Pole. So what movements affect me there, stood on this hill? So we have the rotation around Earth. And this is the rotation that's constant. And if this is what's involved, yeah, a constant, and we wouldn't feel any movement. But as you stood there, there's another constant as the Earth is traveling around the sun. So them two constants act independently on me stood on top of that hill. So as it revolves, the relationship between this constant tangential velocity and this velocity around the sun changes. And if that changes, the speed velocity along this route changes. So as we move to there, it changes again. That relationship of them velocities and directions changes the velocity of me on the hill. So
Loving these slides, Chris. I haven't seen these before.
no, I've just done them today.
Nice.
So if I go back to there, I'll just do a quick vector explanation. So that vector there will be that long. So what it is, you've got a combination of that velocity there, that velocity there. So that equals the velocity of the two.
So it's like a cumulative velocity or cumulative acceleration or whatever, yeah?
And as we move to there, our velocity will get, I'll explain how this works later. So there, that will be the putting the two vectors together, that will be your velocity at that point, because you've got two forces acting on one point. And as we get to there, that would be about that long. So we've got within 12 hours, these three changing velocities along that route. So that's how much it's changing in 12 hours. So you might not think, well, that's not very much, but it is quite a lot. You're moving on average by 2 centimeters velocity. So if you imagine you're on a train doing a constant speed of 10 miles an hour, and you move your cup of tea by 2 centimeters in 1 second. Now, would the cup of tea wobble and possibly spill? Yes. Would you feel it if you were in a little car on that train doing a constant speed and you moved it by 2 centimeters? Yes, you would. And it's more than 2 centimeters per second. It varies as it goes round.
Well, yeah, and you would feel it as it would change from one direction to the other.
Yeah, so I'll get us that bit again, because it's not...
Sorry to interrupt, Chris. Just there is the point where the ballers will argue, it's only this, it's this much, it's all that kind of nonsense.
Yeah.
The point is the effect is there, and as small as it would be, qualitatively, it's there. So it really doesn't matter whether it's enough to send your cup visibly displacing things. That's kind of an irrelevant point. The point is the effect would be there. It would be certainly measurable with the equipment we have.
Definitely. You've got it on your iPhone. You've got sensors on that would be able to measure it. You can put your iPhone on with the sensors and just tap the side of the desk, and it senses it. So it'll sense any movement, and there's none to be detected. So I'll just move on to my next slide, if we can get it up. All right, I'll just bob up straight. Can you see that?
Yep.
A video. Right, this is the ISS. All right, so this is combining the vectors. Here you've got the orientation arrow of which way the velocity change is going in relationship to the ISS, which orbits between half an orbit. So here you'll have the change in mile per hour every 15 degrees of rotation, which takes 225 seconds. So every 15 degrees takes 225 seconds. And this will show the changes in mile per hour. This will show the acceleration in meters per second squared, here and here. So watch the animation. This green arrow is the 17,000 mile per hour of the rotation of the ISS. And the blue arrow here is the movement around the sun of the ISS, because it's doing both velocities at the same time. So I'll play the video. So watch, as it moves around, this dashed red arrow changes length, showing you that it's changing velocity. So this velocity every 15 degrees, it's changing by that much. The speed is increasing.
I'm loving this, Chris. Where's this from?
From my laptop. So it's changing velocity by that much every 225 seconds. This is the ISS. Not only that, here it's changing direction, the velocity. So this would be impossible. You can't say, oh, gravity holds and stops it from happening and free fall. You've got that change there happening in that direction. this amount as it rotates. So here's your resultant speeds. As you're moving around in that, this is just half of the rotation. So this half of the rotation, you're increasing in velocity. And then this half, you decrease in velocity. By the same amount there, then it decreases as it moves around to here again, and then the whole process starts again. As it moves, the rotation moves around the sun. This you could not sit in an ISS reading a newspaper. You'd be bashed from side to side. You're doing 8.25, 8 meters per second squared acceleration. Every second you're moving by an extra 8 meters. It's just impossible for them to be out in the ISS.
Unless you believe in gravity.
No, even gravity. Gravity. How can gravity?
Because it's magic, mate.
Changing direction of the acceleration on the ISS.
I know.
It's the orientation of it's changing as it rotates.
Chris, you can see on there you've got the meters per second squared figure that's changing, and that's kind of the one that's what we're feeling when we relate it back to the fairground ride and staying outside of the lovely shape of those vectors. That demonstrates it. It's that really is the point, and you know it's scaled, but that's still an acceleration and a change in two supposed almost straight lines, as the ballers would try to portray these functions, even though they're both not only curved but elliptical. But even though they're portrayed as two, it's that twist of the two straights and how the variance of the two varies that acceleration. That is the effect that you'd feel, and it's beautifully done, mate. Wicked.
So it's not just a change in acceleration; it's a change in orientation, and that's happening to us on a ball if their model's correct, and it's happening to the water. The water will be heaving up and splashing down, and the momentum would build up. We wouldn't be here. We'd wipe out.
Am I right in saying, though, as though this is the ISS, you've got you had the moon in the other animation, with it basically having to accelerate to its fastest acceleration and decelerate to the negative of its fastest acceleration.
I've got all them figures, but it's not as dramatic as us on Earth or the ISS.
But would I be right in saying that because the Earth is meant to be going 67,000 miles an hour around the Sun, then at some point in its orbit it would be going minus 67,000 miles an hour around the Sun?
Yes. Well, I've got something I've just come across today, and I'll show you the website.
Excellent.
A brilliant animation change around.
Nice. Cheers.
This is where it gets into the headbender, isn't it? When you extend it to that orbit, and then you've got the orbit around the galactic centers, and that's where it becomes even more farcical.
Yeah.
I mean, Chris has got it to take it apart with just two variables. As we were saying with this 3, 4, however many they need to paint next time to fill another hole in their model.
Have you ever seen this? It comes from Walter Beisland's blog. It's a physics map of the Earth's rotation.
No.
I know I hadn't seen it. I found it today. It was, someone sent me a link.
I think Adam might have.
Walt Bisland stuff, yeah. He's the one with the nonsense perspective introduction. But anyway, go on, sorry.
But he does make some very good models, as far as I can tell, and they're not just pro ball Earth. Like, they can be shown to prove other things. Anyway, I'll shush.
Well, this is a globe explanation of how the universe works, or the physics of it. Now, we've got Earth here moving around. We've got the moon circling here. But look at this rotation, these marks here. I can't remember what these are called. This is it. You can see the moon's accelerating and decelerating. The only object going around that circle at a constant velocity is the Earth, the middle of the Earth there in this model.
It looks like Leonardo da Vinci's.
Yeah, so that's the sun, the moon. But imagine the moon is not, that's the edge of Earth as it's moving around the sun. So I can zip to the galaxy. And this, speed it up a little bit. This is all the movements that's happening as you're zooming around the galaxy.
Yeah, you'd never feel that.
No.
Of course you would.
But it's just, it is quite a good physics. And this is from a Globo who's made it. I think the guy who's actually made it has been talking to me on my channel. I recognise the name. But you're doing loops to loops.
It's ridiculous, isn't it?
So,
it looks like bollocks to me.
yeah, well, obviously, they're not saying it's going that fast. But the main speeds we're talking about, we're just looking at this small section here of rotation. Treat the moon on here as a point on the equator. This can't remember what this is called.
We almost need to put someone in a sensory deprivation chamber and have them on a platform, like a flight simulator platform or something.
Yeah.
And slowly spin it or whatever, and have them report inside as to whether they feel it or where they think they're going, like up, down, left, right. It's almost that, to be able to show that you would absolutely feel things like this, you know?
Well, we could tie you up, put you in a black van, blindfold you, and drive around for a bit. See if you
That sounds fetish-ish to me.
You'd feel it, wouldn't you?
I think you would, yeah. I absolutely think you would. And looking at these, it doesn't really matter how slow the Earth's rotating or travelling around the universe or whatever the figures they want to put on it. I think we all instinctively know that you would feel it. I mean, we've all been in a lift, we've all been in a car. You can feel when it goes from 60 mile an hour to 59 mile an hour, and someone's taken their foot off the accelerator or something. They don't even have to hit the brake, but you can feel it. Or whether they're going around a 1 degree turn or a 10 degree turn, you'll absolutely feel it. But it'd be lovely to sort of independently prove that in a chamber of some sort.
Well, mainstream physics proves it with rigid body rotation. So can you see that as you change to a YouTube video?
Before we get onto that bit, Chris, I've got the summation from your video. But if you if you could just go back to that, is that based on the moon rotating around the Earth? So that mechanics
rotating around the Earth.
Okay, so that mechanics, that second orbital mechanics, is based upon an orbit of once a month. So in 12 times, it will do a full orbit of the Earth, the moon. But if we were to translate that to the ISS, it's doing what? I don't know, 18 orbits.
145, 90 minutes.
Right, so
you can
instead
also
of doing 12 orbits a year, it's doing 18 orbits a day or something like that.
Yeah.
Look down now, draw those circles. See what I mean?
But you can also draw these circles of the Earth around the sun.
That one gets worse, doesn't it? Let me line up the other video, guys, and then.
Okay. Can I just point one thing out? We've got here acceleration due to rotation. It has an explanation and orbits. Is a rotating planet orbiting a sun a non-accelerated system? No, orbits are accelerated motions, and an object on the surface of a rotating body is in an accelerated state too. And then it just goes on, you can measure it, and then it doesn't mention it again. And all the maths doesn't mention it. It mentions centrifugal force, gravity, acceleration due to the moon, Meakin, whatever that is, sun's gravitational pull, and it doesn't talk about the rotation moving. That's it, that you can measure it. That's the only section there.
How inconvenient.
Yes, so they mention it there, and then they just go, oops, that's it. So it's like they tell you, but then they just go, thank you very much, it doesn't matter. And that's all physics does, is mentions it, and then jumps across it, and then talks about everything else. Gravity, centrifugal force, the pull of the moon, the pull of the sun, and tides, and then ignores that physics.
Like you said earlier, Chris, they like to take it out and put it in its own separate box and not...
Yeah, that's exactly what they've done. Yeah.
I first came across this when I was researching the Celine Dion. With the moon, is that no one, and also measuring the distance to the sun. They mention all the physics, they give you all the formulas and everything, but they miss out the fact the really sort of massive elephants in the room every time, and it's very simple, and it pretty much throws all of us off. No. Unless you know what you're looking for.
Unless you work it out, but it takes a bit of digging. So they ignore that movement in all the maths. Totally. This doesn't account for anything. It's zero in any of the maths. So, okay, Adam, do you want to go on to the next one?
Yep, right, guys. If you're stopping sharing, cool. Let me quickly share with you guys. I think it's this one. Share. Where is it? I've lost the bloody thing. Bear with me, guys. Sorry. After this one. No.
I'd like to give a shout out real quick to the guys I went doing some activism with on Monday. We had Scuba Dracula, Critical Inception, Just Jack Flat Earth, and Authentic Intent himself was out there with us. It was awesome. If anybody, I'm not a go out and talk to strangers type of person. That's never been my thing. I'm a lab rat. But it's really easy once you get out there. I had so much fun doing it, and it's just, a lot of us, we all have this knowledge that we've been gathering for these last 4 or 5 years. And it is, when people are willing to listen, it's so easy to share it. So if you haven't tried it and you know a few people in your area, it helps if you have a banner, and it helps when you have a couple people. But give it a try. It's a lot of fun. I enjoyed it a lot.
Respect to
and
you.
And I'd like to get a Critical Inception. He's trying to get 1,000 subscribers so he can start live streaming his activism. He's been doing it for a while. Really good guy.
Oh, good. Stick a link in the chat.
Yeah, I did.
He'll get at least one.
He spammed it.
Yeah, shout out Scuba, man.
Scuba too. I'm going to throw his in there.
Chat just a bit earlier.
I've not had a chance to look at your video. I saw them pop up, but I've just been doing other shit. But yeah, I'm looking forward to looking at that. But respect for you to getting out there, man. Jeez.
It was fun. It was a lot of fun.
In the Iron Realm t-shirt, Zach.
Yeah, that's right, baby. Represent.
Right, guys, are you ready? I'll share with you if you are. As soon as I can find it. There he is. Okay, guys, I'll press play and there we go.
Right, so let's wrap up with the physics. Rigid body rotation with translation, which means a rotation that's moving at the same time. Look at the links below in the video description. So we have a point on the equator of Earth. 2 points. This is the North Pole looking down on Earth as it rotates and moves around the Sun. So these 2 points, as we rotate and get to here, are moving at 67,000 miles an hour. Both of them. Well, the tangential velocity of rotation, moving 1,000 that way and then 1,000 that way. So you do the vector addition for both, link below in the video. There's a 2,000 mile an hour difference in velocity over 12 hours. So, short video of the calculation. It's impossible for us not to feel that amount of acceleration. That's what the vector addition tells us. That's what we should be doing if we're spinning and moving through space. The ISS destroys the space illusion using rigid body rotation with translation physics. ISS, orbiting Earth. It's doing 67,000 miles an hour. Same as Earth. These 2 points. Again, using the tangential velocity, 17,000, 17,000. Do the vector addition. If you know physics, you'll know what a vector addition is. So here, what speed am I doing? 50,000 miles an hour. There. What speed am I doing here according to the vector addition, sorry? 84,000 miles per hour. So once you do that over 45 minutes from there to there, that's half an orbit, 45 minutes. Every second, the ISS would have to be moving like a Ferrari in this direction. The orbit stays the same, but the direction that it's going with the sun, around the sun, is dramatically changing. It would be impossible. It'd be squashed tomatoes.
Brilliant.
Give me 1 second, guys, and I'll just quickly drag the final.
That's testament there that I didn't watch the video before this show, and that's no slur on you. I've obviously been doing other shit.
Right. Okay. So I'll just share it with you guys.
But once again, you answered the exact question that I was hoping you were going to answer.
What was that?
Well, how the Earth and going around the Sun, how that was affected. I mean, you showed the Moon going around the Earth and how it would speed up and slow down, and also now how the Earth goes around the Sun and would have to speed up and slow down as well.
Yeah. It's total madness, the ball argument. Yeah. Once you start digging down on it, we're getting better at pulling it apart. I think it helps because we're getting battered by trolls, so we've had to get better.
They have their uses. They
Hey,
definitely
Chris.
have their uses.
They do indeed.
Chris, isn't the sun also moving though?
Yeah, but if you put all the other dynamics into it, it's just a massive washing machine within a washing machine within a tumble dryer, and it just doesn't work.
What, not wheels within wheels?
Yeah, as soon as you put this rigid body rotation physics in play, nothing works. That's why they hide it in the classrooms, they hide it in all the lectures, everything. They talk about it very, very off the subject. They never talk about a sphere moving. They always talk about a stick or some inanimate object, a cat revolving, never a globe moving through space. It's just ignored.
You talk about hiding it, mate, and this is, for me, the geeky bit. this last. It's only 40 seconds, but this last bit is the bit where you show where they've hidden it and where it can't be hidden, which is in these vectors. So let me just do this last bit and then I'm done pestering with your vids, guys. There you go.
Look at the animation. This is showing the vectors as the half of the rotation. The red dashed line shows the resultant vector of the two vectors as it rotates. And note it gets bigger as it rotates. This shows that we're getting faster as it rotates. That point on that rotation is moving faster as a result of those two vectors.
I'll tell you what, I never quite understood vectors, but I do now. And yeah, cheers for that.
There's a simple way of doing vector additions that involves no maths. It involves a ruler, a protractor. And there's a link on the video to how to do it with a ruler and protractor. Really simply.
Ah, sweet. I'll have a look at that.
Yeah, I never understood vectors until I saw that diagram, the arrows going around it, and that was.
Oh, that's brilliant. Yeah.
Yeah,
it's like the cumulative effect of all the forces added together and given a direction. Well, it just makes perfect sense.
You can add loads of arrows together, and it shows you really easily how to work out all them vectors, how they act on a one object, by just placing the arrows and then measuring from point to point with a ruler. Will tell you how fast you're going. It's what they use for ships at sea, because the tide's going that way, the wind's going that way, we're going that way.
Exactly.
To do. It's not complicated maths.
No. It's just the word vector. It was never fully explained to me. Adam, you're fired. In the words of Mike Kavanagh.
I get blamed for it, won't I? Yeah, I'll take it on. Thank you, Chris, for enlightening Mr. Savage there.
Okay, thank you very much.
I've failed.
I'll forget by tomorrow anyway. No, don't worry.
You watched the video.
Yeah, exactly. I've got it bookmarked now. No, seriously, I think that video is absolutely awesome. It was showing me the exact things that I was hoping you were going to show me, and I think it's brilliant. I've got a feeling that this has way more legs, and you've got an experiment coming up and all sorts, and like I said, I'm getting giddy, so I'm going to bail out at this point. Sorry guys, but I've been up since TFR's Ironworks as well, and if I thought about it, I could have been on there this morning.
Well, that would have been awesome to have that happen.
It would have been, but unfortunately, yeah, never mind. Another day. Anyway, guys, appreciate it. I'm still on cloud nine. I'm going to sleep like a log tonight, a burning log, and I will catch up with you midweek, guys. Love you lots.
All right, John. Love you, brother.
Love you. Make sure you got a nice thick thing to grab that hot steel with too, that iron. You don't want to be like half asleep and just go and grab it, because that thing will bite you.
I know what you're on about. I'm not sure anyone else will though, but yeah, cheers buddy.
Love you, man.
See you later.
Later. That's the first goodbye of the evening.
We'll see.
He's piped early tonight as well, hasn't he?
I was thinking it's early still. Yeah,
He'll be back.
It's because he was up since Ironworks. You know, somebody in chat actually said this earlier too. I think it was Smee. This is all great for spinning balls in space, but you throw this into the ISS, and I mean, you know, with its spindly arms and all its bits and bobs and wires and batteries outside that are constantly needing changing or replacing, or yeah, it would be torn to bits the first rotation around.
Are you still there, Chris?
Uh-oh. It sounds like we have audio issues somewhere.
Somebody's clicking. Probably Savage nodding off. Was it you, Josh?
It's Josh.
And then earlier, I saw something. Apparently, Bob wants you to do the actual real speed differential vector mass of 1,300,000 miles per hour. I don't know what that means. I just thought it was good.
I got cut off then. Sorry. 1 million. Yeah, easy to do.
Yeah, that's the speed of the Milky Way moving around the Great Attractor, I believe.
That's it. The Great Attractor.
Well, there's
That's
some
what's
links
in the
on
model.
video.
What Marvel book was that?
So Chris, I've got a geeky point to make.
Okay.
It's one of the. I was putting my baller head on when I was watching this, and you were talking about the importance of the actual orbit with regards to the translational effects of these two directional speeds. Can you just maybe elaborate on why it's one particular orbit?
Well, do you mean it's not the rotation and the angular velocity stays the same for the globe, and the linear velocity of the Earth around the Sun, that velocity stays the same for the center of the globe, but it's the orientation of the velocity to that velocity. It changes as it moves around. That's what changes. The only point on a spinning ball that's moving at a constant velocity that way is the center. So the center's moving at a constant velocity that way, and it's rotating at constant velocity. That's the only point that's doing a constant. Everything else that's revolving is moving at different speeds, constantly accelerating and decelerating. So you've got like, is it a body in motion stays in motion unless acted upon by another force. So that motion that way is affected by that motion that way. So that constant disappears, moving in that direction. Does that answer the question?
It does. Yeah, it does. It does. I was probably more angling it towards the magnitude that we were talking about in terms of the plus or minus 17s and the lights, and the magnitude of the vector is affected by the orbit. So it's important that we're talking the orbit is opposite. If it was within the line of the translational movement, then it would kind of be massively negated because we just have one change on one line. So this kind of fits in with the ISS because you picked one particular orbit, which is the
one close to the sun's terminator line.
Yeah, so it's gone that way, but I'll elaborate. My point being, I think this kind of accentuates another issue with regards to the ISS and how it orbits, because for each different orbital path, there would be it would necessitate a different rate of, because we're talking 3D here. Everything you've shown is 2D, but actually when you translate it to 3D, every slightly different orbital path that's off of those two right-angled orbits, one we're showing nothing, the other, but all those transitionals in between are going to require the thruster guy on the ISS to vary his thruster rates based on the angular orbit and its relative angle to the secondary motion. Does that make?
Yeah, I understand. Yeah, it'd be impossible because we've just showed like 15 degrees of rotation in sections, and if you do knock it down to 1 degree, it's still moving at incredible velocities across that 1 degree, and the direction's changing of the velocity. So, do you understand? So you've got a fixed point of the ISS, it's spinning around and changing velocity. So it's impossible to account for that, and the orbit's changing as well, and then so the velocities are getting less as it moves away from that key orbit, but they're still there and they're still massive amounts. So you go from hardly any to tons of acceleration, within a day. It's just impossible to account for that. Yeah.
Well said. That was. Are we going to talk about the your one idea? Were we going to cover that tonight, or was that a Wednesday sneak peek?
Well, that's up to Chris.
What's that? The experiment?
Yes.
Yeah, we can do a little bit on that. It's not fully thought out and worked out. I've got all the equipment to set it up. So, yes.
Yeah, you don't have to if you're not ready yet. I love it. The concept is so simple and easy, and those are the great ones. The ones that are so obvious. It's like, wow, how could nobody have thought of this before?
I'll do it on the whiteboard if I can. I did have some graphics somewhere. I can't find them.
Do you need any help, mate? Or I've got the.
Have you got them two drawings? Oh, sorry. There you go. This might do it. Can you see that?
Yes.
All right. We'll start off with that one. So here we've got this apparatus set up here. So that's a force meter, which is that. Can you see that? That's a force meter with a little hook on it.
Yeah.
Yeah. So I've got two of these. So we've got one set up there, one set up there. Now these measure mass, and they're accurate from 5 kilograms down to 1 gram, and they're accurate to a gram. So this setup is measuring the centrifugal force that's supposed to act on us on a ball spinning. So here's an I'll go to this one. No, sorry, go back to it. So here's the Earth, there's the center of rotation. So at this point of Earth on the equator, the centrifugal force is moving and pushing in that direction by 0.34% of the mass. So if there's a mass of 10 kilograms, 34 grams will be lost because of supposed spin of Earth. If we go to 45 degrees latitude, we're losing about 20 grams of mass, measurable mass, up there. So this is what the experiment is there to test, whether that amount of force is applicable at that point. So it's a hard point. They've had all the equipment set up. It'd be quite easy to show you, but I'll try my best with this. So we set this apparatus up here, and we place it on our 45 degrees latitude in this orientation, because the centrifugal force is pushing out that way. So it's pushing south, and it's pushing south by 0.20% of the mass. So we've got a 10 kilogram mass here. We would weigh off these two force gauges. So if we have it in this orientation, west to east, the centrifugal force acts on it in this direction.
Right.
So both force gauges will, if the setup's balanced and accurate, will show the same reading. Now, if we spin the apparatus around north-south, the centrifugal force is now pulling that mass in this direction. So the readings on these 2 meters will be different. So all you've done is you've got it balanced, level, you spin it round, then you measure again. And then these would be different readings. And then you can spin it round again, completely the other way around, to double check your readings and see whether the meters change to be the same as they were the other way. Now, it's early days with the maths, the vectors and everything. I've given them to Adam and a physicist to double check what I've put on and what I've worked out. I did speak to a physicist at the conference and he was really excited about it, but he's come very quiet. So I'm waiting to feedback on all my figures. I'm setting up the apparatus to do the experiment. So basically, if the Earth spins, there's a centrifugal force where I am. Well, this is set at 45 degrees. Well, I'm at 53 degrees, I think, latitude. So it'd be about 70.17%. So I've got the equipment to test it all, set it up, put some forces on it that should be equivalent to that 17 grams to show that the apparatus will measure that amount of change. I'll set it all up, prove it works, demonstrate it working, and then find somewhere to set it up and show it that it just shows nothing. But there might be a force there, we don't know. So we know the Earth's not spinning or moving, but there might be a magnetic force that's pulling and pushing. So if it does, then we're after the truth. So if it shows that something we think, well, it shouldn't, but we still got to put it out. That's the way it should work. So that's the idea. It's early days. Well, it's moved quite a lot, but I just need people to check my figures are right. I'll put this together in the next few months, and then hopefully it'll be exciting times. Because I've come on.
Now, how much did this cost? Your little apparatus that you built?
Well, these brand new are about 450 quid each. I've got 2 of them. Well, I've not paid that much, but I've had a little bit of help of Spencer. Thank you, Spencer.
I would like to see this done on multiple latitudes. I think that would be a really neat way to check it out.
Well, the best latitude would be 45 degrees latitude because that's the biggest effect we'll get and the measurable effect. But like most of the ideas I've had, they end up they can be mega expensive to do them properly.
Yeah. Well, this is just brilliant. I love it.
This one's simple or pretty simple, and hopefully we'll be able to set it up and get it moving. I've got all the bits, got all the meters, got everything. High tension, very thin cables. So I've using a bowling ball as the mass. So I've just got to make sure it does the job that I'm saying it should do. There's no reason it shouldn't, because it's so simple. But you've got to make it so it's accurate. I was hoping. Sorry, go on.
I was saying, I dropped a link in the chat we're in here on Zoom for y'all, I guess. I saw Nathan Oakley in chat talking about the Evetos effect. I'm probably saying that completely wrong, but I put the link. Say it, sorry, for me.
Yeah, boss.
Thank you with your inflections and your emphases.
Yeah,
but anyway, I just thought that would be something that maybe we should look at. I'm not sure. Since I'm not the math guy here.
I just dropped the link into the chat.
Right.
I think this is my only thing is I think my only critique is I think you need much more sensitive weight.
Well, again, I don't know the details, but according to Nathan, the fundies use this as a globe proof of some sort. Again, don't know. You guys should maybe talk to Nathan.
They're globe proof that you can buy gold at the North Pole.
Exactly.
Buy it at the equator and sell it at the North Pole. And You'll be rigged.
Yeah, the beauty of this is it's in one position, one set position to prove it. They're carrying a weight from one latitude to another and saying, look, it weighs different. This is just done on the spot, possibly in Rochdale, in a little concrete bunker somewhere, and it just blows it out of the water. There's no traveling around the world carrying a kilogram weight and weighing it.
I think this is one of those things, mate, that it's you may be a liken to Airy, in that the result will obviously be zero, and therefore it'll be known as
Chris's failure.
Chris's failure. Yeah.
Claim to fame, but well, this is the first time I put it out. Actually,
I think
it's
it's brilliant.
People to look at. Harry and I have done some filming on it, and we've done some talking on it. So we're hoping to, when we set it all up, that he'll come down and film some of it. But you're quite welcome to, once it's set up, we can meet up and talk about it and see what the best thing to do with it is.
I would love to, mate. I'd love to. I'd bring the iron staff, but it's winging its way to the States.
Yeah, I'll be wielding power here soon.
Use it only for good. Only for good.
No promises.
But I keep thinking I've run out of ideas, and I must keep coming up with new ones. But
mate, I think the experiment thing is one thing, and requires rigorous setup and stuff to
observation
point. Yeah. Empirically, you need to gather this data, sir. But for me, your video, mate, and I want to give it another massive shout out, because we aired less than half, maybe half at most, of the thing, and within it you explain the whole concepts of the implausibility of what's being suggested really, really well, mate. And I just want to give you a massive kudos for it, mate. It's wicked.
Thank you.
Work.
I think it's more powerful than you think it is, because it just blows it all away with their with physics, mainstream physics. But people just, with all their arguments, they're just ignoring it and just explaining how the Earth works, in the books, and they ignore this physics. I said, well, how can you ignore it? And they don't say anything. But thank you very much. Yeah, it took a while. It took 12 months to get here, but and it is more complicated than it looks, obviously.
Well, you didn't just, think, hey, this doesn't make much sense. I need to make a video about it because this is what I think's going on.
Yeah.
You went out there in the trenches and you were in threads and chat rooms talking to actual physicists and posing these questions to them and honing your response and your arguments and refining your questions. And this wasn't just a spur of the moment thing for you.
Well, if you look on my channel, I've got some physics questions that I posted up, so I could specifically go asking questions and point people to the video, and then say, well, what's the answer? And no one can give me an answer. Some of the physics teachers that I spoke to never had a clue what I was on about rigid body rotation. Some of them didn't even know what vectors were, and they taught physics. It's like, what? Who are you teaching physics to? I'm not a master of physics, but I know about rotation physics now, and I can explain it to anybody and fight my corner on it. But it's exciting times, I think. Who thought we'd be living this life now that we're fighting and seeing these changes? Brilliant.
If you would have told me 10 years ago that I would be out on a street corner telling people the Earth was flat, I would have laughed for at least like a year, probably, right in your face.
Well, we all would. Yeah. Well, but what a magical time, isn't it?
Oh, I know. It's beautiful.
Yeah.
If I could pick a time to be alive, this would be it.
Definitely. Everything's changing. And Martin Leakey stuff changing the whole outlook of everything. But yeah, I think people are pulling together a bit more now. Some people are dropping off, but things are moving up.
the community's growing. I think if we ever look at any one individual to be a statement of where the movement's going, that's a fool's way of viewing it, and probably what the way the ballers would like to liken things. Oh, look, that person's disappeared or whatever, and that means it's fake. You know, this thing's growing exponentially. You know, Zach, I agree with you, mate. If only 3 years ago, 2 years ago, and we were just starting out, you told me I was about to head off on a camper van that had been tarted up to look like it does. Do you know what I mean? And I'd be piling out at tourist spots around Italy, ready to flat smack people. I did a guy today, mate. This was wicked, right? So a guy comes in, and I'm just serving him, with the guys. And I tell he's not English. I couldn't tell where the accent was from. So I'm just chatting to him anyway. I was, but where are you from, fella? He said, Macedonia. I'm like, no. Says that's where the tour bus is going. Milenko, is it Milenko? Yeah. I forgot the guy's name. I forgot in the shop. I had to look it up online. Started typing Dave. Look, Dave Macedonia. And I said to him, oh yeah, he's met up with Milenko, the guy that said. He's like, no, brilliant. So I gave him one of the leaflet that Roxanne's had smuggled into me suitcase, returning from Amsterdam. And I said, have a look at this. And he said, can I keep this? I said, yeah. He's like, well chuffed. Off he went. He says, I'll be back. So yeah, wicked, mate. It's a mad trip. God knows where we'll be in another year's time, Chris.
Have you done street activism before, Adam?
Yeah, I've done a bit. I mean, I do like over the counter activism, mate. Yeah. I grab people in the shop, but I'd done a bit a year or so ago when the first tour came to Nottingham. That was great fun. And obviously meeting up with the guys then, and then obviously a bit more hardcore stuff in Amsterdam, which was fantastic fun. Really good. Guess it's got me the appetite, Chris, for Italy. I'm ready.
But I did it with Harry for 10 days on that tour, the first tour. And don't forget, you're doing Italy, and you'll realise how hard it is. And Harry did all of it, all the way through, from beginning to end. And you'll know how hard Harry worked on that tour last year. Yeah. You'll understand once you've done a bit of the tour for a few weeks. And he did it for weeks and weeks at a time. So big kudos to Harry for doing the first one and having the tenacity to carry on and do it all to the very end. And you'll realise how hard it is when you do it.
Well, we'll mention his absence. He was here in midweek and was coming on, but he's texted and said he's decided he wanted you to have the kudos, and quite rightly so, mate, because this is your
well, it's a big thing to Harry. I think I wouldn't have been so inspired to do what I've done without Harry's help.
I'm with you on that, and I think that's why a lot of people wanted to see Harry tonight, and I'd said to him, a lot of people love you and for the inspiration you have given, and I said he gives you the best hug in flat Earth. It's a proper bear squeeze. And,
I know a lot of people are missing his work. I know that. But he's sorting himself out, not because he's sorting his life out and he's nearly there. Perfect. So yeah, and he can do whatever he likes. So
yeah, more than, and he's welcome anytime. And shout out to Harry, and yeah, we'll see you soon, dude. And I enjoyed just saying hello briefly. I know we were rambling in midweek like we always do, but there you go. But yeah, shout out Harry, and sorry guys for him maybe not seeing his smile tonight.
He's probably smiling at home somewhere.
Yeah, well, it was to give you the showcase, and quite rightly so, mate. I think what you've presented is not only a great concept, but as Josh said, you took it on and you've made it understandable. And again, I'll
even for me, and that's a big one, my friend. Don't worry, I'm definitely the math stunted one here for sure. So to from Wednesday till today, I've even gained some more understanding of the whole thing, especially the experiment, or I'm sorry, the test, the observation, whatever it is. At the end,
I put forward two new things I've not seen before. It's been talked about. So this should invigorate a few people to go and work on things and work it out for himself. But yeah, brilliant stuff. I'm glad people are seeing it now. But there's more ideas in the other videos as well, so go and have a look at them. I've got a gyro one. I've got a field of view one.
Just on the off chance that we don't have it in the description, which is very possible, tell everybody where to find all those amazing videos, please, Chris.
If you type Chris UK on the YouTube channel, it's a bit disorganized and got a few bits on, but you'll find the videos on there. And there's some great videos on John Smith's Global Eye. They're all on there. He's filmed a few things. I've got a few small things on by myself, but Harry's got some great videos. The Field of View video, Simon Dan grabbed all of it, and he had like millions of views on it. So it was obviously hitting a button somewhere. So I've been hammered twice by Simon Dan. Once for a gate experiment and another one for the Field of View, because I got an equilateral triangle wrong, something stupid.
It'd be interesting to see if you get any decent critique, mate, because the nonsense ain't worth responding to. But if there's any actual real considerable, like I said, you've spoke to real proper physicists that have
I've had some heavyweights on me on this video, and they're not coming up with anything. They just say, "Oh, you don't understand." I go, "Well, actually, I do." So that's all they got.
Well, it would seem their get out clause is to show how this force is not applied, because they're surely not suggesting the forces are not there. That would deny their model. So they've just got to suggest how they mitigated, I suppose. And like you say, don't let them out of their box. You know, they want to keep it in a box, but it's clearly not. These are all interlinked movements.
Well, the best argument I've had against what I've put forward is that actually the Earth's not moving around the sun, relatively speaking. So it's not moving. And I thought, well, if the Earth's not moving relatively, and then relatively speaking, we're not spinning, then relatively speaking, everything's moving around us. Isn't that what the flat Earth has been saying? So it just fell flat. He went, oh, I went all quiet. Well, that's probably the best argument I've had that wasn't really an argument.
Sounds like bullshittery to put it in a box.
Yeah, it was bullshittery, yeah. And nothing else relative. They keep trying to push angular velocity doesn't change. Well, I say it doesn't change. I'm not on about angular velocity. Well, if it doesn't change, then it doesn't make a difference. They just don't want to look at it. People refuse to do the vector additions. It's just madness how quiet it is on the comment section. When this is powerful stuff, I think it's powerful. Yeah, and thank you for showing it. And I got a bit of encouragement off you, Adam, because I sent you a video a long time ago to have a little look.
I've still got the USB stick next to me, pal. It's part of my flat Earth memorabilia, mate. This. It's not in John's box.
Well, well, mentioning it to you and at the conference to one person, hundreds of people saw this video that's unlisted. And it kept going up and up and up. I thought, what the heck's happening here? I only told two people, and it just spread like wildfire. Yeah. Yeah. So a bit of history. You never know.
Yeah. Legend for me. Mate, it was like you say, it was a long time ago when you sent me that memory stick. So and it exemplifies the level of work you've put into this and the concept and the level of critique you've took and worked with before releasing it. So like I said, I look forward to seeing if there is anything of any merit that's worth consideration in as a retort. So I look forward to it.
Yeah, and well, if you get anything, pass it on and I'll have a go at it.
Yeah. All right. Well, thanks, mate. I'll if Josh is there,
I think he's here.
Do the segues. I don't know what we've got, mate. That's me done. I'm burnt out for tonight. Just as hopefully that the significance of tonight's presentation, and like I said, it was really well done, has got over to everybody. I think it's an outstanding piece of work that, and I titled it in the thing that we're going to presuppose, and it is presupposition, because we're working in their paradigm, but that's the beauty of it. You can have all this fun, and and it does exemplify the ludicrous nature of what the suggestions occurring when we compare it to a little bit of reality like that fairground. Cheers, Chris. Thanks, mate.
Yeah, amazing, man. Thank you.
Yeah, thank you very much.
Yeah, that was awesome.
Thank you.
I've had to
I'd like to give a shout out real quick. Nathan Oakley.
Yes.
Just had his 1000th show.
That is so awesome.
I think that's the first Flat Earth show besides maybe Pancho Pete's, who was a 24/7. I don't even know if they made 1,000 on one channel though. I'm not sure. But that's a great achievement there, Nathan. Well done.
Yes, it is.
I sent him a text earlier, Josh, to say congratulations. He said thanks, but and then I said, actually, I'm going to have to retract it, because if I remember at least 30 or 40 shows with Spurs Chemo going on about in gas pressure, I reckon he has to subtract a few. They can't count.
Ooh, good call.
But no, shout out, Nathan, mate. It is amazing, isn't it? 1,000 shows and the level of viewership that shows this Flat Earth isn't growing at all. On that, whilst we're on that theme, just one more shout out, Zach. I think QE is in full effect tomorrow. He's called all the ball busters, and I think he's got everything set up, Discord, everything. So I think that should be 8:00 tomorrow, UK. I don't know what he's got, fireworks or anything else special planned, but I think he's ready to go full time instead of just testing stuff. So I look forward to that. And yeah, it's 8:00 on QE Pop Me Razor channel. That'll be ball busters. So that'll have me, assuming Nathan, Arwin, Riley had better turn up, I assume, and the rest of the guys, Betty and Paula, hopefully. So, as they say, be there or be sphere. Be here. Otherwise, Nathan will tell me off. Be here or be sphere.
Damn.
Sorry, Walt.
Put that in your pipe and smoke it.
Yeah, neither the book. Shut me up. I'm going to mute.
Put that in your pipe and smoke it.
We need to get a One Big Love line in there. They got so many. I love their one song though. Got a hole in my bowl. Plug it with a nugget. Yeah, it's cool music. It really is. I'd like to get those guys on one night.
That sounds a good shout.
Make it happen.
Ask them if we can have their tunes. Use a few of their tunes as well, because always fun.
Yeah, they're real cool guys. I don't think they'd have a problem with that. I'll ask them though for sure. Well, I don't know.
I don't know. What? What don't you know?
It's only been 2 hours and some odd minutes.
I know, right? I don't want to kill it. We don't have to.
I know.
Chris, do us another presentation. Come on.
Yeah, I have got another idea.
Good man.
Oh, thank goodness.
We've got all these people that can do live streams all over the world. So why don't we simultaneously, as the sun comes round, time the sun as it comes up? Have all these cameras pointed at where the sun's coming up or going down, and just live stream them all, put them all together and go, oh, look, it's popping up here, it should be there. We could do something with it.
Like Nathan
I
Oakley's
think we could.
I know I got
Sorry.
right.
Oh, like some
2.0,
people do it
isn't
with
it?
the moon, haven't they? And you could do it with the moon as well.
I mean, we could do that on Zoom right here. Have people just use their phone and turn the camera, and they could sit there and just show the sun coming up from wherever they are with their phone.
It'd be a long show, wouldn't it?
Yeah.
Well, we can get up to like 100 participants in these calls, possibly even more.
Yeah,
but I'm pretty sure we can show at least 100 thumbnails of people's
Sunrises.
different videos as they pointed up at the sky.
Or show them how to set it up on a tripod and it come over and then next shot, and then go, well, it doesn't work. What's going on here? And something's going to come up, isn't it? It's just something no one's done. I've not seen it.
Yeah, Antonio Subrats tried it.
Yeah.
They didn't hit it, all of them. I was actually a part of that one. I jumped on and ran out there in the morning at work. It was cold. I think it was January or February, something like that. I remember it being real cold, snowy.
I didn't put a nail in a board, Zach, right? But I remember watching as it occurred.
So has everyone got a P900?
No, I have the P610, the one smaller.
Because if you look at another video I've got on about a field of view, everyone take a picture of the same constellation of stars at a set focal length all over the world with the P900. Just switch it on, point it at the star, press it, and then all the images get put together, and we can get a program that counts the pixels between the stars to see if there's any difference in distance. Because if something's further away, it'll be less pixels than it'd be closer.
That's like Riley's thing that will make him jump back to the ball if the ballers could provide that data with regards to southern star observations, like between the three continents in the south of the equator. Nearly said it, didn't I?
No one does it at a fixed focal length. They're all zooming in and zooming out. I've not seen anything where they've all done it at a fixed focal length. The same camera taking the same image at the same focal length all over the world at the same thing as it moves around. Does it get further away and closer? I think if you have a quick peek at the field of view video, it's on Harry's channel. It's on my channel.
The nearest to that is theory. Remember Adam, Josh, that did the star maps, so the circles, and replotted them all north and south rotations to give one star field. That would be nearest to see if those observations then were matchable with his layout, because it was only really the Southern Cross that went a bit skewy in that, wasn't it? With regards to his changing it to a almost azimuthal type projection, because it's all bulk data, isn't it? So.
Yeah, I was just trying to find out whether the stars are closer in some parts of where we live than other places. You'll see the idea if you watch the video anyway.
Well, I did that years ago, was to kind of look at the relative angles and distances and see if I could draw any triangles, trying to plot. I think I used Paris and London. So it wasn't far. I'd just plot some star constellations, see if I could draw some triangles there, and nothing adds up. Even there, it was like, that doesn't make any sense. But I remember abandoning that project years ago, Chris.
Yeah, there's a few in there.
But again, the abandon, it's a Meakin's failure sort of thing, isn't it? It's again, it shows that there's the data isn't translatable to. I think more importantly, it's probably not translatable even to a flat plane. Never mind a ball. I think there's more at play. for what we see.
I think I've got some ideas on it, but I've not quite worked them out yet on what's happening above us. Yeah, but I'll mention it when I get it a bit clearer in my head.
Zach, I think the point I make is it's kind of coherent from any one point, but when you try and merge that same data, it doesn't overlap. The FE Core did it, didn't they, with the sun tracking of their almost toroidal layers of it. You know what I mean? It's perfectly coherent from your position and your data, but that isn't.
To me, it shows that we're not seeing a physical object, whether the sun be physical or not. We are seeing it being reflected through layers of atmosphere, and it could be degree or two, or I don't even know how many degrees off. But I've measured it myself. I did 8 months every single day out measuring the sun in the morning, and then at midday, and then in the evening. And I caught it 3 different times where it was off by 2 degrees, which is a huge amount in the sky. That's like 4 sun lengths away. Like there's the sun, and then you stack 4 suns, and that's how far of a distance it was off in the sky. So it's even where it's supposed to be in the sky. I mean, now that's through 8 months of at least 2 measurements a day. Sometimes, I didn't see the sun here and there, but it was a lot of measurements. And only 3 different times was it off by more than like half a degree. I gave myself half a degree error. It was my first time using the sextant and all that kind of stuff. I got real good at it though. Near the end, I was always like right on. I wouldn't even check the U.S. Naval Observatory first. I would go and just do it and then mark it down, and then I would go look, and I was always within 0.2 degrees, somewhere right around there. So yeah, it can happen even when it's supposed to be where it is in the sky, where we know it should be. It isn't always there. So being able to see it from different parts of the earth and trying to triangulate it, I think would be not possible, just in my opinion. It's still a fickle mystery to me. It drives, I look at it and say, what are you, all the time? How do you work?
Do you think could be within the firmament itself? Beyond the dome, in the water, just inside the water, or on it?
I've been having thoughts that there's more than one light source to the sun lately. And we just see the focal point of all these beams converging. I've been looking at eclipses lately and how shadows start taking place, and I'm not sure. It's I don't know.
Have you ever watched A Very Clever Turk?
No.
No. Very Clever Turk. He did a video about there being 2 suns. But yeah, there was a few problems with the land mass and everything. But I thought his idea was like, wow. It's a bit off the ball, but it shows I think I've got the video on my channel, one of his videos, a link to his page. It shows a figure of 8, the sun moving. So if you have a look on my page, it's there somewhere. Yeah, Very Clever Turk. Yeah, he's a clever bloke. Well, yeah.
I'll check it out for sure. Thank you. Yeah, I was infatuated with the sun, and then once I realized that I have no idea what it is, it just drove me to where I didn't even want to look into it anymore. And then I haven't done the moon yet. I've done some research on the moon, but I don't know what they are. I mean, they could be anything. I don't know. I think we're not meant to know. That's this feeling I get.
Well, Dave Marsh is doing extraordinary work with the moon.
Yeah, absolutely.
You won't beat his work, I don't think, what he's doing.
Yeah, we had him on a couple months ago, 3 months ago, maybe, something like that.
Yeah. I think, Zach, the sun and moon are a bit different. I think For me, the moon has more less variance in its location. It may be wrong, but certainly for me, the sun is more. It's not necessarily an aberration, but what you see is more a reaction in the atmosphere, or the atmosphere plane, whatever you want to, determine it. But the actual image you're seeing really is a resultant of the atmosphere plane above you. It's a lot more related to that, the image, whether that's distortion, that just the level of moisture changes what you're seeing. Do you know what I mean? As simple as that. But to me, I think it's a lot more affected. I say probably falsely so, thinking less. The same with the moon, but
I don't know if anybody's have they tracked the moon, tried to triangulate it? Any flat earthers? That'd be interesting. I know they both wagon wheel in the sky. They both change size. I think the sun changes size between 5 to 6 degrees a year, and or 5 to 6%, sorry, a year, and then almost 2% every single day. A lot of people say it doesn't change size, but the Royal Observatory confirmed. Chris Van Matre called him after he had measured this, and they were like, "Oh yeah, that happens every day. It's how it works with the solar filter and everything." But then the moon does, I think, 11%, maybe 13%, something like that. The moon changes size a lot more than the sun does. So yeah, I'm not sure. It's a puzzle.
I think the only one that I know anything about is one that we took part in way back in the beginning of all this, that we all tried to do a moon. Oops, sorry. I didn't know my phone was turned on. My apologies, and my shout out to Rob. Anyway, it was like the 24th of January photo shoot or something like that. And we all were trying to track the moon. I mean, we had people involved from all across the plane. Raven Locks was a big instigator and all that. But that's the only time I know that we tried to do anything all at once on the moon. I think everything has been pretty much focused on the sun that we've all jumped on. So it definitely is something we could approach, trying to organize.
Yeah, absolutely. I think Dave Marsh might be the man to contact.
There's a hashtag somewhere on Twitter with all the coordination of that event, but I am having hell trying to figure out what it used to be. It's not saved in my my current phone. That was a tablet or two ago. Let me see if I can find it.
You know what?
If John was still here, he might remember. He was part of all that. I think that was actually before it. Like, I know it was before Zach was here. It may have been even before Josh was hanging out with us.
I think I remember you out there. It was right before I joined, because it was like 35 degrees and you were out on the water. And was that it? When you
No,
were
that was me going out
moon?
that was me out there doing the lunar eclipse.
That's right.
That was happening. That was happening as the sun was a lunar eclipse. That was happening as the sun rose behind me in the sky. So that was fun. But I'm trying to find.
Savage is still here. Oh, I can see him.
Let's give him a shout. Savage!
Come on.
Wake up. He's all warm and toasty sitting there.
No.
Wake up! Savage!
Combo.
Oh,
Josh, I need some lettuce. Let's have some lettuce.
You read my mind, Adam. You read my mind.
You rang.
We actually have probably a big pile of lettuce we never got to.
Let's
I had
get
to play the old microphone switcheroo game. I don't know if it was the cord or if it's the microphone itself, but the 8-ball is down for repairs.
You rang?
permanently.
There
well,
he is.
John, do you remember the hashtag for that 24th January moon thing that we all did across the plane way back at the beginning with this? Ravenlocks, and I think even our buddy down in South Africa was there. What was his name? Too many years ago. Yes, exactly.
No.
You don't remember it either. The only one I can find is my erroneous one that I keep looking for. Apparently that's not it. I've got 3 of those I've put up that keep popping up, but it wasn't the one I'm remembering. Apparently I can't find it. If I can find Ravenlocks, I bet you know.
I remember a couple of years ago we were taking moonshots almost every night.
Right. Well, no, this was like all of us doing it on one night. It was like 24th of January. I remember because that's but I can't find a
I think that was part of my impossible moon phase expeditions. Yeah.
Yep. I think so. I think it showed us all some interesting things. But I don't know. I'm not finding it. I'm just finding my putting it up
when we have to go to Savage for his memory.
Right. I thought that even as who am I asking for memory?
Yeah, on that note.
Thank you, sir.
My memory's gone to bed.
Good night, sir.
Good night.
Throw again, John.
Right,
I want lettuce. I don't want foam. I want lettuce.
We're going to sing together, okay? Tiny bubble.
What do you mean you don't want foam?
I heard a bit of foam. The nonsense.
Hey, I found it. I'm sorry, I got excited. It was hashtag 24th Jan Moon Shoot. I dropped the link there in chat if you guys want to go see what we did way back in 2016.
Yeah, that rings a bell.
Yeah, I see John Savage all over it with the shots.
I'll have to look that up.
Ravenlocks, James. Oh, James. I forgot about our buddy Oak. He hasn't been around in a minute.
What's that? James in Exeter, is it?
Yep. Our resident actor.
Yeah, good man.
Great believer. Truth Frequency News was even in on that.
That would be
Seven Spirit, Phantom Ring. I'm just going through the list here. I'm excited to have found it. Sorry to interrupt. My bad.
I bet you Lucky doesn't realize that was Ironworks way back then.
Way back then. Oh wow! That's who that is? That's
Sure.
Lucky.
That's Lucky.
Oh my God! I didn't even realize that. That's nuts. Hey, Lucky. Small plane. Awesome.
That's good stuff. No, I don't want to get into the foam either, really, Adam.
Yeah, it was kind of silly.
I remember that Walter going through that this morning, and I don't want to.
It was painful. Yeah,
and
it was painful.
Foam just undersells it. They're not just bubbles,
No, they're universes. They're small little universes.
These are universe computer bubbles, as I recall.
Exactly, universe computer bubbles. Band name. No, I guess that's more like an album name. That's not a band name. Universe. Yeah, that's album name.
That's the little interlude that comes about a third of the way into the album.
That's the hidden track on your 13th album. That's what that is.
See, this is why I said lettuce, not bubbles.
Lettuce we didn't get to quite a bit.
I'm actually trying to get the pile up in front of me here. And that's proving to be a bit of system pull with my lovely slow resources. Stop telling me that. You don't know what I've got going. Man, it's not happening. Skype is not happening. What else did we talk about this morning?
We had all sorts of stuff that
I know. There's a show about it and everything. Where is my pile? There it is, finally. Sort of, kind of. Oh, that's right. We talked about Eddie Van Halen taking pictures.
Now, is the speed of gravity, does that have to do with the bubbles?
No, that was something we didn't really get to.
It must equal the speed of light.
Turns out that not only are we all like paranoid us Twitter people and us YouTubers. We have a reason to be paranoid, apparently. For the 77th Brigade, which I can't find at all in the story. Where's that story you dropped?
It is right there.
My system is not cooperating, man. I'm gonna have to close stuff and try to get to this a different way.
It's right under the fluoride video.
It's not flowing for me. You're gonna have to grab it.
So apparently there's this guy that Twitter hired. He was responsible for the editorial section of Twitter in the Middle East and North Africa, it says, with editorial responsibility for the Middle East and North Africa. His name was Gordon McMillan. Not only was he a Twitter executive, but apparently also a reservist officer in the British Army's Psychological Warfare and Propaganda Unit out of the 77th Brigade, an outfit that was formed in 2015 to conduct, quote, information warfare, end quote, and develop, quote, non-lethal, end quote, ways of conducting war. This according to a report that was published in Britain's Middle East Eye, revealed how McMillan served with the unit for several years. Twitter, of course, downplayed McMillan's links to the Army and said it supports its staff in their external volunteer commitments. Bunch of bootlicking bastards. Twitter is an open, neutral, and independent service. Really? A spokesperson for Twitter said to Newsweek, "We do not allow our data services to be used for surveillance purposes or in any other manner inconsistent with people's expectation of privacy. Employees who pursue external volunteer opportunities are encouraged to do so in line with company policy." The spokesperson added that we proactively publish all tweets and accounts relating to state-backed foreign information operatives on the service, regardless of the source. We built this industry-leading archive to promote better public understanding of these threats. What a bunch of garbage. The British Army has also distanced itself from Twitter, apparently. There is no relationship or agreement between the 77th Brigade and Twitter, other than using Twitter as one of many social media platforms for engagement and communication, a spokesperson said. The Army does not comment on specific activities of reservists working within the division. So, there you go. It's just one big coincidence.
Right.
They love you.
Well, as a side note, thanks to, I believe, Twitchy in chat earlier, I did a little research here on the show while we were live into, I love to do that, John, into CENTCOM. This is a 2011 Guardian report about how the Department of Defense awarded a $2.76 million contract to the government contractor Intrepid to create fake internet personas and use them to spread U.S. military propaganda online.
Evening, Walter.
The U.S. military is developing software that will let it secretly manipulate social media sites by using fake online personas to influence internet conversations and spread pro-American propaganda. California Corporation has been awarded a contract with the U.S. Central Command, CENTCOM, which oversees U.S. armed operations in the Middle East and Central Asia, to develop what is described as an online persona management service that will allow one U.S. serviceman or woman to control up to 10 separate identities based all over the world. The discovery that the U.S. military is developing false online personas known to users of social media as sock puppets could also encourage other governments, private companies, non-governments, blah, blah, blah. This is a 2011 report that I'm reading. So that's 8 years ago that this was all uncovered, easily known about, and there it is. But no, we're all just paranoid as fuck about bikini stains and